Our project was based around biomedical instrumentation and aimed to develop a wireless heart monitor, also known as an electrocardiogram or ECG. We then planned to explore further applications for the sensor, including processing of other body signals. Our starting point was this circuit board, which was based around a programmable mbed microcontroller. It included Bluetooth to make the device wireless, an SD card for data storage, USB ports for programming and power, and an ECG chip to process the data from electrode pins. We first had to program the mbed device using C++ programming to correctly process the data from the ECG chip and send it either to the SD card or to a computer via USB or later Bluetooth. Once sure that the computer was receiving the correct data, we used Python, another programming language, to write a plotter for the data. This was a greater challenge than expected, as we had some trouble with translation of the data between the programs. But eventually we got the plotter working and managed to wirelessly transmit and plot ECG traces of our own hearts. Having succeeded with the heart, we moved on to other signals. As you can see, we were able to produce distinct traces and signals with various movements. Trace 1 shows left to right eye movements, and trace 2 was produced by blinking alternate eyes. Traces 3 and 4 are examples of different muscle activities we measured. Trace 3 shows bending the arm, and 4 more sensitive thumb movements. Excited by how distinct the signals were, we moved on to programming animations in VPython. The ball on the left is the most basic example of VPython. We edited the program so that the ball bounced off the surface in time with the heartbeat of the person attached to the sensor. Then, using signals from the eyes, we programmed the virtual face on the right and made it copy eye movements. This is a video of it in action. We nicknamed it the Eyecatcher. Our ideas for further applications for the device were primarily medical. On the left is the most obvious application, as a portable ECG which at-risk patients could use to Bluetooth data to their phones, which can then be emailed to a doctor. The sensor can also detect moisture, hence the bedwetting alarm idea, and can be used to monitor muscle activity after surgery, which is very useful for rehabilitation. We were particularly interested in the tracking of eye movements as an application, since this proved so successful in our project. Research showed that unusual eye movement patterns can indicate brain tumours, epilepsy or psychological conditions, so the use of our device in this way really interested us. We also considered the commercial gaming applications, providing a new way to interact with computer systems, similar to current devices, but more flexible. Our project succeeded in its goal of producing a wireless heart monitor and plotter, and we were really proud of the success of utilising other body signals. However, I think the most exciting thing about our project is its as yet unexplored potential and its many possible applications.